Alright, Section 5, Installation Distribution System. 5.1 Overhead Method. General, with each of the overhead line design with refer to DM4 2, the limitation of the overhead line should be avoided in the following location. Electronic facility with the clearance of the overhead electrical power line with the electronic facility refer to DM12-1. The airfield with the installation overhead line with the airfield with the clearance they avoid it entirely with the regulation imposed by the Federal Aviation Administrator of the Air System Command. Loading air with the pilots and floating air with the overhead crane with the operation clearly aerial electrical power lines. Industrial areas. Congested industrial areas shall be clear of the aerial lines requirements of the ammunition storage of the air given with the Military Handbook 1004-46. Limited lightning protection addition with the Navy COP5 of the ammunition explosive ashore with the delineates the concerned with the overhead line with the magazine facility. Underground method. The average condition of the prevail with the underground with construction maintenance with the more expensive the overhead installation application should be limited to the factors beside with the economic dictates. Example of such factors indicated by the paragraph 5.1.2. Alright, application. Underground electrical power distribution systems are normally resistant to the damage of the surface of the atmospheric distribution and with a simple performance to have the overhead system. Expandability with the growth of the factor extremely important for the end of the design with the underground electrical power system. Some of the capacity as well for the provision of the future crossing road ways, runways, and taxiways shall be included with the design referred to paragraph Military Handbook 1004. For the power distribution system with the detail of the underground controls, instruction design criteria for the selection of all indirect burial systems. 6.1 Critical Section 6 Level of the distribution voltage. Alright, we're going to continue reading this. Alright, 6.1 Critical coverage of the distribution system that have the medium volt at the level of 2.4 to 35 kilovolt for the covered in the section except for the 4.16 kilovolt below the 400 Hz distribution system. The criteria appear for the DM4 0.05. The system of the utilization voltage for the 600 volt below are covered in the Military Handbook 1004. Electrical utilization system generally with the majority of the system supplying with the primary distribution low voltage for the Navy activities over the 15 kilovolt less over the however the voltage applied above 15 kilovolt may be encouraged to have the utility volt supplying with the Navy the installation with the distribution volt for each of the capable distribution design and value with the cost of the individual distribution energy loss and adapt the most economical voltage level the overall point of view. System volt the electrical power may be generated at the site with the purchase of the power generated site with the criteria with the electrical power generated with the side with the name of the DM3. Purchase energy. When purchased electrical power is used, adapted the most electrical voltage tank in consideration. Transformer switch give the control equipment and energy loft. The 24,000 volt system. The 24,000 volt system total capacity does not exceed the 5,000 kilovolt amp. The utility company services the voltage. Where predominantly motor load includes the motor rated at 200 horsepower. More such motors can exist for the use the direct connection of the motor starting equipment at 4,160 volts over the system of the 4,160 volt system. Maximum demands exceed 7,500 kilovolt for the utility company deliver the electrical power. They have the voltage level of switchgear capable of 4,160 volt, giving them more economical installation than the one of 24,000 volt load, including the motors of 250 volt horsepower over in the group of the motor for up to 7,000 kilovolt amp than the 4,160 volt system that may be economically than any other voltage level. The 6,900 volt system. The 6,900 volt system only with the utility company delivers the energy level that there are special consideration. 12,000 volt to 13,800 volt system. These systems can be economically with the demand of 7,500 kilovolt amperes. 15,000 volt to 34,050 500 volt system. The system is economically with the demands of 20,000 kilovolt amperes over, especially with the distance involved and are considered. Alright, 7. Grounding of the distribution system. General equipment. The distribution system with the equipment with the low impulse of the string, for example, the underground cable, the dry type of transformer, the rotating equipment should be the effect of the ground to avoid serve the loads of each of the individual section. The circuit should be the ground with the only ones for the short of the side. But the action of help the control of the ground, the fault of the current. The ground fault relaying with the detailed discussion of the distribution of the system. The ground was covered in the ASI standard 142 in 1982 with the IEE recommended practice of the ground industrial commercial power system. ASI IEE standard 141 1986 with the IEE recommended the practice of the electrical powers distribution by the industrial plant method. The type of the character of the ground device shall be limited the maximum line with the ground fault with the current with the 3 phase fault with the select of the ground connection with the type of the given in paragraph 721 through 723. This solid grounding with the solid ground system shall be U the automatic clearing with the ground fault with the U the only secondary system wherever the impedance of the transformer is equal with the zero current sequence current path with the connection with the avoid with the grounding of the generator where the zero sequence ground fault current with the generator terminal below with the 3-phase fault current over the which of the generator's brace or additional branch for the recommended practical restrictions applying with the system ground connection refer to the ASI IEE standard 141 1986. Resistance grounding. The resistance grounding of the system is applicable for automatic clearance of the ground fault, limiting the ground fault with the current to the safe value, reducing the mechanical stress caused by the ground fault current, and this type of connection by the Y-connected generators for the transformer of additional guide for the recommended practice. The restriction applying with the system, the ground connection referred to the ANSI IE standard 141 1986. Reactancy ground. The reactancy ground system is applicable to the ground generator system and the automatic clearing of the ground fault. When the consideration type of the grounding, remember the variable of the ground fault current shall have the value of at least 25% of the three-phase fault current in order to limit the transient of the voltage during the clearing of the ground fault. For additional guidance of the recommended practice restriction applying to the system grounding connection refer to the ANSI IE standard 141 1986. Alright, section 8. Selection of the distribution system. Selection factor within select for the distribution system. The design must consider the load requirement, the personal voltage regulation, reliability, flexible life cycle cost. The system is available. The various system the recommended for the use of our medium voltage distribution system unless noted otherwise are described in paragraph A2 through 1 through A2 11. The conventional system, the radial distribution system, the conventional radial distribution system figure 5 requires the minimum transformer capacity because of the advantage of the total diversity among the loads of the required less space for the main disadvantage of the flow, flexibility, power of the voltage regulation, and not much reliability, but the simple fault in the main box must be shut off. The completely capable cost of the energy losses are high, but the system should be ordinarily limited to the 1000 kilovolt amp, the maximum demand of low voltage distribution system. 822 modern simple radial distribution system. The modern simple radial distribution system, see figure 6 can be used with the capacity and the cassette for the 1000 kilovolt amp low voltage feeder for the cap of the minimum reducing cable cost energy loss. See each of the transformer to handle the peak of load of the area server. The main inconvenience of the system is that the fault in the primary circuit can shut off the service of all the transformers. Alright, 823 modified modern simple radial distribution system. The modified modern simple radial distribution system figure 7 provides all the advantages of the modern simple radial system and type that include the important improvement of reliability. Initial cost of the hours is higher. 824 loop of the primary radial distribution system. Loop of the primary radial distribution system figure 8 with the same characteristics is made of the modern simple radial distribution type, in addition with the provide the quicker restoration of the strip of the primary feed of the transformer fade with the eventual lower insulation cost energy loss than those of the aim of the distribution system previously discussed. 825 the bank secondary radial distribution system. The bank secondary radial distribution system figure 9 provided the quick restoration service of the whole system after the primary cable fault of the transformer failure with the secondary loop of the emergency supply through the effective air is equalized with the load of all the transformers permits taking the advantage of the diversity among load gaining the transformers capacities allows large motors to start across the line in terms of the secondary loop of the greater flexibility, high efficiency of the good voltage regulation contribute contribution to the all transformers connected with the parallel within the system should be taken into consideration. 826 primary selective radial distribution system. Primary selective radial distribution system differs from the modern simple radial distribution type of that and uses 2 or more primary feeders. Alright, this shows your conventional figure 5 shows the conventional simple radial distribution system source of the PART5, the transformer, the main distribution board, circuit breaker, the feeders, your load circuits, and load units. This shows your modern simple radial distribution system source of supply, main breaker, the transformers, behind the circuit breaker, behind the switch and the circuit breaker, load centered, load circuit with the feeder for the, and then your transformers and fuses and your load units. The source of supply, main breaker, the circuit breaker, transformer, brakes, switches, load center, the circuit fuses, load circuit breaker, the primary feeders, load units. That's your modified modern simple radial distribution system. This one is your load primary radial distribution system, source supply, circuit breaker with the switch of the load center with the transformer, the load breakers, Y connections, load primary feeders, disconnection switch, and load units, the load circuitries. Alright, this is your bank secondary radial distribution system, source supply, circuit breaker, disconnection switch, and then you have your transformers, Y's connection, fuses, load centers, and secondary ties, and the limited or luggage load primary feeder of the transformer. Supply source circuit breaker with the transformer selective switch, load center, load circuit and primary feeders, and this is your primary selective radial distribution system, figure 10. Instead of one of provided with each of the feeder with enough capacity to carry all the load of the extra investment with this, and provide the alternative primary with the selector switch with the compensator with a quick restoration service of the van of the primary feeder Failure. Secondary selected with the radial distribution system. Secondary selected with the radial distribution system. Figure 11 that compares the duplicate with the feed with the secondary above located at the center of the compensated for the any with the full multiple function of the primary feed with the transformer common configuration both of the pair of the unit substation connected through the normally owned secondary tie circuit breaker of the primary feeder over the transformer failed with the main circuit secondary circuit breaker and the effective of the transformer is open with the circuit breaker of the clove of the operating may be the manual automatic normalization operating with the radial system with the loss of one primary circuit with the transformer. The total substation level may be supplied with the one feeder with the one transformer to allow for conduction of the one combination of the following alternatives are applicable. Oversight of the primary feed of the both transformers of the one transformer care with the total load. Oversizing the primary feed of the providing force air cooled by the transformer to strip of the emergency period. Shielding non-essential load with the emergency period. The oversight of the primary feed of the temporary overload with the capacity of the transformer. Accepting the loss of the transformer life. D42 the each of the transformers each associated with equipment shall be capable of carrying essential load of the bowl section inside the transformer taking into consideration allowing overload. 82 simple network distribution system. Simple network distribution system. See figure 12 must be with a high density heavily concentrated load with the main advantage for the network distribution system and continue with the service and kind of involved in the system that automatically with the fault, the flexibility, adaptability, shifting load with the good voltage characteristics. 8281 network protector. The network protector supply with the forward power into the network avoid the feedback when the primary line clears any of the fault automatically. 8282 limitation main object of the network system is the initial cost involved with also the secondary type of the extent with the considerable distance and probability of the fault occurring is greater. 8283 secondary loop. The prep of the advantage for the secondary loop is the same as the bank secondary radial distribution type of the paragraph. 825 the number of individual capable setting of the connecting loads connected to determine the reliability of the system. Installing limiter lugs of the cable side of the bale to end of the secondary tie with the side of the ties of the should be able to supply with load any load centers on one secondary tie. This shows your source of supply, the circuit breaker, the primary feeders, your disconnection switch, the transformers, load circuit, and fuses, and then your transformers and fuses and double-ended load centers. Secondary selective radial distribution system. Source of supply, circuit breaker, primary feed, transformers, network protector, disconnection switch, fuses, secondary circuit, secondary ties, load circuits, limiter load centers, network protector. And that's your simple network distribution system. Alright, 829, simple spot network distribution system. Simple spot network distribution system, figure 12 of the may should be installed with a heavy load with the concentrated the small area of the considerable additions of should be between such load with the system should be inherited with the network system. The system leave the however because it is not provided. Secondary alerts refer to paragraph 8283 with additional information. 8210 for the primary select of the network distribution system. For the primary select of the distribution system, figure 12, figure 14 should be the industrial application for the heavy load with the eventually distributed E for the primary feed that should be capable of carrying the entire load of the primary selective of the V or network distribution system to provide the continuity of the distributed within the event of the one primary feeder or the transformer failures. 8 to 11, the primary selective spot network distribution system. The primary selective spot network distribution system. See figures 15 provided the most of the reliable electrical power distribution in the event of the primary feeder failure. Transformer connected to the unfolded primary feeder that can carry all the load in the short period of the time that it takes for the transfer of the other transformer to unfold to the feeder. Each transformer need not to have the total capacity of the load time. And this is your supply source circuit breakers, primary feeders, transformers, network protectors, and then switches to transformers, primary network, container load circuit disconnection, network protector load centers. That's your simple spot network distribution. This is a source supply circuit breaker, the primary feeders, switch selected with the transformer network protector with the load circuit, the disconnection switch, transformers, load secondary tab, load centers, limiter, left network, and protectors, load centers. Source supply circuit breaker, that was your primary selected network distribution. This is a source supply circuit breakers with the transformers. Circuit breakers, the network protectors, load circuits, transformers, primary feeders, and then your switch, selective switches, network protectors, load centers. Alright, bibliography. Documenting the insurance coincident factor relationship included with the appendix B, the distribution diversity benefit of the maximum non-coincidental method demand for the electrical utility allocation manual available from the National Association of Regulatory Utility Commissioner in Washington, D.C. 2044. Chapter 4, Operational Economics. Electrical utility council team the variable available at Columbia University, Press, New York 125. Military Handbook 419, grounding and building shield electronic equipment facilities, and then that was your government publications. We'll just skip that part and we'll go to Military Handbook Standard 461, electromagnetic interference characteristic requirements for the equipment. Military Handbook 411, long haul communication power, DCA power, environmental control, physical plan of the Military Handbook 1004, 2 power distribution system 1004, 4 electrical Electrical Utilization System 1004-6, Lightning Protection 1190, Facility Planning and Design Guidelines, DM3, Mechanical Engineering Services, Series DM12-1, Electronic Facilities Engineering, FCGS WL305, Light Set General Illumination, ABC OP5, Ammunition Explosive to Shore, Ocean 926, 403, 1986, Battery Rooms and Battery Charging. Non-governmental publications, i.e. ANSI Publication Institute, Electronic Engineers Incorporated, ANSI 235-181, Emergency Eye Wash and Shower Equipment, i.e. 45-11-16, Coincident Factor Relations with Electrical Service Load Characteristics, Recommended Practice Electrical Power Distribution of Industrial Plants, i.e. 142, Recommended Practice for the Grounding Industrial Commercial Power Systems, 446-80, the Recommended Practice of the Emergency Standby Power Systems, IEC C281 Natural Electrical Safety Code, and then we'll go over the National Fire Protection Agency Association, number 70 Electrical Code, and 110 Emergency Standby Power Systems. And that was Military Handbook 1004-1, and your Unified Facility Electrical Engineering Preliminary Considerations.